Okay, you guys know your little reminder of your quadrants, 1, 2, 3, 4. Anybody remember where 1 was? Top, top, top. One, then it goes counterclockwise. Yep, 2, 3, and 4. Okay, all good? All right, what we're going to start doing is I'm going to give you a degree measure, and you're going to draw that angle on the graph. Okay, before I do that though, a couple terms. When a graph is in standard position, which most of our angles will be in standard position on the graph, you will see one side on the x-axis. Everyone see that on your paper there. One side on the x-axis. That's what we're calling the initial side. Okay, always. You will always have the initial side on the x-axis. The other side, though, depends on the angle measure. That's called the terminal side. Okay, that's called the terminal side. That could be in any one of the quadrants. So does everybody see an angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Okay, now before I get into actually graphing these, anybody know what type of angle is formed right here with this x and this part of the y-axis? 90 degrees, right? So if I start at 0 right there on the initial side and I go up to the y-axis, that's 90 degrees. What do you think it is right here as I go another 90 degrees? 180. All right, let's keep adding here. What do you think it is at the bottom here of the y-axis? 180 plus 90. 270, yes? And then we're back at 360. Okay, then we're back at 360. So ready, here, quick quiz. I got an angle of 100 degrees. What quadrant is it going to end up in? I got an angle of 100. Second quadrant. I got an angle of 265. Third. I got an angle of 300. 4. I got an angle of 45. Angle of 45 degrees. First quadrant. Is everyone all right? If I list out an angle measure, you can now tell me what quadrant it is before we graph it. All set. Okay. So the first one I need your help graphing is 145 degrees in standard position. So we know that the initial side is on the x-axis. Now you got to tell me 145, what quadrant? Oh, look back if you need to. 145 degrees will end up in what quadrant? Second quadrant. Now, here's what I don't want, is you just to draw a random arrow somewhere in the second quadrant. Be in the ballpark of 145 degrees. What I mean by that is 145 closer to 90, or is it closer to 180, or is it just halfway in between? That's what you got to figure out, because I want you to at least have your drawing in the ballpark. So is 145 closer to 180 or closer to 90? Or halfway in between? Is it directly in the middle? I don't think it's directly in the middle. So it's closer to what? 108. Do I need to review how I know it's closer to 180? Okay. So then draw your, what side's this called again? Terminal side closer to 180 then. Okay, draw it closer to 180. Now we're still not done, because you'll learn in a second the angle could go counterclockwise or it could go clockwise. I need to see which direction you're going in. So what else you need to add to your diagram is what I call a rotation arrow, saying it's going this way. All right, that's the one I want you to look at for 145 degrees. going that way. All right. I'll turn it over to you guys now. 30 degrees. What quadrant am I going to be in for 30 degrees? Here we go. Yep. 16. What quadrant? First quadrant. So initial side still on the x-axis. 30. Closer to 0 or 90? Closer to 0 or 90 degrees? 0. So make it look closer to 0 when you draw in your terminal side. Only thing missing, get a rotation arrow so I know which direction you're going, clockwise or counterclockwise. $295. 295. What quadrant am I in? 295. 6. What quadrant am I in? 295. Quadrant 4. Yes. So I'm in quadrant 4. Am I closer to 270 or 360? 295. Where's it closer to? So draw your terminal side closer to 270. And then rotation arrow. Label with what? The degree measure? I need just the rotation arrow to show me where I'm going. Any questions there? Yep.
When do you know it's going to go the other way?
Right now. Okay. Angles can be positive or they can be negative. All right. First time you guys are experiencing that probably in your math career, that you can have a negative angle measure. Now it goes clockwise. When the angles are negative, it goes clockwise. So for instance here, we got 0. Now I'm going this way. Guess what this angle measure will be? Not just 90, negative 90. And then what am I going to be here? Negative 180. Up top, negative. There you go. So when I go clockwise, it starts going negative. So what quadrant, if I need you to draw an angle of negative 60, what quadrant am I going to be in? Here we go. 11, what quadrant would negative 60 be in? The 4th, correct. Nice job. Closer to negative 90 or 0? Because I got to draw that arrow somewhere. Is negative 60 going to be closer to negative 90 or to the 0 degrees? Negative 90, so make sure your terminal side looks like that. So now when you draw your rotation arrow, it's going to go clockwise. Yep. It's the clock. Yeah, clockwise. We good? Okay. Any other questions? All right, now I got a challenge for you. Big challenge. We just did negative 60. Can you name me a positive angle that would look just the same now? Can you get me a positive angle that's the same exact diagram as negative 60, except now the arrow would go that way instead? Can you do that? Everyone, I'm asking you, everybody. Can you get me a positive angle measure that's the same as negative 60? Because if you can, you're basically doing the hard work for me today. Jenna, what do you got?
I did positive 290.
Positive 290? What do we think? I hear 290 and I hear 300. Can't be both. How'd you get 290?
It was like, because 90 minus 60 is, it's like, wait, I don't even know math anymore. It's 3. Oh, wait, never mind. It's 200. 300.
300?
Yeah.
We all in agreement? 300? Okay, whoa, new vocabulary term now. New vocabulary term. 300 and negative 60. 300 degrees and negative 60 we call coterminal. Coterminal. Because, what's this side called again? The side in the quadrant? That's the what side? Look back if you have to in your notes. That's my terminal side. They share, coterminal angles share the same terminal side. Okay? Now, I'll be honest, guys. I don't want to have to do the diagram every time. Is there a way that you could have went from negative 60 to 300 pretty quick without looking at a diagram? So if I give you an angle measure, another negative angle measure, you can give me the same positive one in return pretty quick. How'd you go from negative 60 to 300 pretty quick? How'd you guys get that 300? That's what I'm asking. Alex, how'd you get the 300? You add 360 to it. All right? So that's what it is here. If an angle is negative, we add 360 to find the smallest positive angle. Okay? You're going all the way around in the opposite direction. Got that, Mary? Coterminal, they share the same what? Terminal side. It's the same angle, but in the other direction. Okay, on you guys. Go ahead. Negative 270 and negative 110. Find me the smallest positive measure that's coterminal with it now. I don't need it. Hey, did I ask to graph it at all? No, so if you don't want to graph it, don't. I'm not asking you to. I'm just looking for a positive angle, the smallest positive angle that shares the terminal side with negative 270 on number 5 and negative 110 in number 6. Okay, here we go. Negative 270. What's coterminal with negative 270? Let's rock and roll. 4. Positive 90. Yep. What's coterminal with negative 110? 1. 250. Good. Questions from you guys? Anything else going? You guys didn't have another one, did you, on that one? Because I know I changed the packets. No, you don't. Good. Okay, so any issues there? Okay, what if the angle's not negative? What happens if I have an angle greater than 360 now? Number one, can I graph it? And the answer is yes. So I'm asking first to graph 640 degrees on there. All right, you go all the way around, guys. What's your, where am I? If you go all the way around. 90, 180, 270, back to what? 360. Okay, keep going again. So what do you keep adding on here? 90, so this would be 450. I am still not there yet. Need to see where 640 would be. Keep going, 540. Keep going. I'm still not there yet. 600. I keep adding 90, right? So 630, still not at 640, but keep going, add another 90. Where are you? 720? So where's 640? What quadrant? Quadrant 4. All right, here you go. Same. I'm not going to do anything different until the very end. Is 640 closer to 630 or 720? What do you mean by labeling, Brett? This is the second time you're asking this.
You know, you're labeling.
I have no idea what you're talking about with labeling.
360, the 450, the 540.
Oh, what do you mean on the here? No, I don't care. No, I'm just showing you why I'm trying to show everyone why it lands in quadrant 4 versus the other quadrants. I don't care if you do that or not. No. Okay. So we know that it ends up closer to 630. Here's the one thing that's going to change. Your rotation arrow. Okay, ready? You're going counterclockwise, right? Because it's positive. But I'm not stopping there. That's not 630. I got to do a little pinwheel action here, don't I? So got to go past it and then stop. Okay? Because that tells me it's more than 360. Marissa.
Is it the same if you do 640 minus 360?
Oh,
That would be-
I'm getting there. I'm getting there. But you still need that rotation arrow going around more than once. Okay? I'm getting there in a second. You're going exactly where I'm going to, which is, can you name another angle that's coterminal with 640? Name this other angle a different way. It could be 640 degrees, or it could be this. Can we get any smaller? How can I get smaller than 640? Subtract what? 360 from it. So go ahead, subtract 360 from 640 and let me know what you get. That angle is also the same as if I graphed Art. 280 degrees, yep. Okay. So basically, real quickly in summary again, what did you guys just do if an angle's bigger than 360 to get it smaller? We did what? How'd you go from 640 to 280? You subtract what? Subtract 360. Okay, let's see who's on their toes with 7 and 8. I'll let you do those on your own. Find an angle that's the smallest positive angle with 550 and 750. Find the smallest positive angle. Smallest is the key there. Yeah, smallest positive angle. And I didn't also see those. Make sure you state the quadrant where it's in as well. State what quadrant I'm in, and then the smallest positive coterminal angle. And you could find, some of you guys, I like the approach you're doing. You're finding the angle first and then finding the quadrant. Good idea, nice idea. Get the angle a little smaller first, then find the quadrant. Might be a little easier. Good idea, kids. Darn right you can, good. I'm going to catch some of you guys, I can see. Okay, number 7 here, 550 degrees. First, tell me What's the smallest positive angle it could turn into? Coterminal. 17. You just get so much enjoyment of telling me that every day. I could tell. I could tell. Because you know how heated I get. 12. 190. Good. And then with 190, I should be in quadrant 5. Quadrant 3. Yep. Okay. So if I ask you to graph that, might be a good idea to find what it's coterminal to, then it's a lot easier to graph. Okay? Instead of going, 550 around and around again. Yep, Brett, what about, I don't know. Can I label it? I don't know. I really don't know.
Actually, I don't know why, but I said quadrant 7.
Quadrant 7, that's a new quadrant.
Yeah.
Just
I went
determined today.
1, 2, 3, 4. Like, 5,
It
6,
starts
7.
1 again. Yep.
Just didn't know that. What did you say?
Okay.
I
Thank
read
you,
it.
Art. I was just thinking the same. Why would you let everybody know that? But the old famous quadrant 7. Yep. All right. 750. I don't know if I got some people on this or not. 16.
30.
Nice job. 30. Some of you might have subtracted 360 and got what? 390. That is coterminal, but my directions say what? Smallest positive one, right? So you can subtract 360 one more time and still get a positive answer out, which is 30. Okay, so keep subtracting till you get the smallest positive. And then no problems here. What quadrant am I in for 30 degrees? Quadrant 1. Okay. Or 5 maybe? 9. Oh, that's right, yeah, because you have to go around twice. I forgot. Yep. Yep. You have to go around twice. Yep. Quadrant 9. Now, did you do a Roman numeral for that? Okay. 1x. Okay, everybody good? Last one we just got to discuss, the only scenario we did not go over, which is negative 400 now. What do you think I do to get a positive angle out of that? Negative 400. What do you think I do? Add what? Okay, if I do that, what's going to happen here? I still get what? Negative 40, but it says smallest positive, so keep adding another 360, yes. So what is it coterminal with? 320 degrees, yep. So the rule is negative angles can be simplified by adding, what are you guys adding? 360 until you find that angle that's between it. All right, go ahead and do it for negative 900. It doesn't look like it. Art just says find the smallest positive measure coterminal. Unless you guys have different directions, I don't think so. And for negative 900, what are we looking at? 7? 180 degrees, yep. Okay, go ahead.
If the angle's 180, what quadrant?
We don't say, good question, it's not in any quadrant. Okay, I actually have a name for it. It's going to come up here in a second. Yep, good question. I was hoping that came up. Anything else? Busy day today. Going? That was the first half. Now I got to get into the second half. Do you feel confident in graphing your own angles? Feel confident? Because that's key to what I'm going to show you the second half of class today. All right. Second half of class, what's a reference angle? reference angle. An acute angle formed by the terminal side and the x-axis. Ready, I'll show you real quick. First I got to introduce a new Greek symbol. You guys were introduced to sigma last time. Anybody know this Greek symbol here? What is it? Beta. Yep, thanks for finally contributing today. All right, something positive. Beta, yes. It's the Greek symbol for beta. It's just, you guys ever see, it's a variable basically. All right, don't freak out about it. It's just naming the angle, okay? So what I need you guys to do, can you set up your own x and y axes and graph 160 degrees for me? That's what I want you to do first. Graph 160 degrees before I talk about the reference angle.
You want like counterclockwise there.
Always draw the rotation when you're graphing. Yep. So I know what direction it's going in. What quadrant you put it in? 2. Did you put it closer to 180 or closer to 90? 180, perfect. So most of our diagrams, that's awful. You don't have to put the 160, I'm just showing. Oh, everyone good there? Okay, how to find the reference angle for it. Go through the definition again. Ready? Acute. Go back to your geometry days. I know, good times. Acute, less than 90, okay? And it's formed by the terminal ray and the x-axis. So the reference angle for this diagram right here would be this acute angle right here. Can you tell me how many degrees would be in that acute angle? Don't yell anything out. Think about it, because that's your reference angle. All right, this angle measure right here, I'm putting in purple, is the reference angle. Acute angle that's formed by the x-axis and the terminal side. Think you got it, Sarah? 20. How'd you get 20? Because you knew that was 180 and that's 160. The difference is 20. Everyone good? So the way we're going to represent that is we're going to put our symbol beta with a subscript of r. Guess what the r is for? Oh boy. What are we finding? Reference angle, yes. So the reference angle for 160 is 20 degrees. Okay? We're just finding them for now. We're actually going to do something with them later on next week. Go ahead, graph 300. What quadrant are we putting 300 in? Quadrant 4? Is that closer to 270 or 360? Closer to 270? Okay. What is the reference angle? Remember, hey, the angle formed between the terminal side and which axis? Which axis? The x-axis, x. Kids always get confused at the beginning. They always go for the y. Never use the y-axis. It's this angle right here between the x and the terminal side. Do you think you have enough knowledge to find how many degrees are in that angle? Go ahead, Brett.
I believe that it's 60 degrees.
I believe you are correct. Thank you. You want to just explain to everyone how you knew it was 60?
All right, so it's a long process. So we have 300 degrees,
Yep.
and 360.
At 360, yep. And what are you doing with the 2?
You subtract.
There you go. Done. All good with that part. Okay, here's what gives kids a lot of trouble. 210 when it's in the 3rd quadrant. Kids, ooh, I don't know what to do here, but I got faith. Go ahead and graph 210 in the 3rd. Go ahead, graph 210 in the 3rd. Ooh, 210. That's closer to 180 than 270. What, Art? Good talk. Okay, some of you, anybody having a little issue here? Finding the reference angle. Hey, it's got to be x-axis and the terminal side. I'm not, hey, look up here. I'm not finding that angle because that's with the y-axis. Here's the angle and find it. What's the degree measure of that angle right there? And it's got to be acute, less than 90. What's up, Alex? Is it 30? Are you confident in that? You want to explain how you got 30?
210 minus 180.
Yeah, instead of 180 minus the angle, now it's 210, the angle I was given, minus 180. So you are correct. Nice job. It is 30 degrees. Everyone see how he did that? He took 210, that angle, and subtracted it from 180. Any issues? Okay, and then I just throw this one in here just to make sure you're awake. 78 degrees. What quadrant are you in? Quadrant 1, right? And I'm looking for the reference angle. Anybody want to chime in with anything here? It's the same angle, right? Don't give me, why don't I want this angle right here? That's not a reference angle. That's with the y-axis. I want it with the terminal side and the x, and it's this angle I originally made. So if an angle is in the 1st quadrant, it's its own reference angle. All right, angle in the 1st quadrant, it's its own reference angle. Ooh, negative 110. Negative 110. Here we go. I think you guys can handle this. First, got to know what quadrant it's in. Okay. Negative 110. What quadrant? 3rd quadrant, yep. Closer to negative 90 or 180? 90, yep. And it's going clockwise because it's negative. What's up, Mary? It's negative, right?
Yeah.
So I go in the clockwise direction, right? Other direction. Do you? I don't care what the degree measure is, but can you guys see where the reference angle is? Can you see it? If I highlight it right now, this bad boy right here, there's the reference angle, and it's got to be positive, and it's got to be less than 90. Do you think you can get it for me? What do we think? Positive, and it's got to be less than 90. What do you got, Nick? 70 degrees. You want to explain to your classmates how you got 70?
I took
Yep. This is 180, right? And you knew this was 110. So what's left over? 70 degrees. Yep. Yes, because that tells me it's a reference angle. Yep. Okay, I'm going to skip around here just so I don't go right. I don't like going right up to the bell here. So let me go to right below, which is quadrantal angles, and this gets to Jillian's question. Quadrantal angles are angles that are not on the quadrant; they land right on the land right on the x or the y axis. So when she asked what quadrant's 180 degrees in, my answer is no quadrant. It's called a quadrantal angle. So there's one of them, right? Name 8 quadrantal angles, 180. Anybody want to name others? We got to have at least 2 which are negative here. 90, I heard. Here we go. Can you get 8, kids? Can you get 8?
360.
Negative 90, yep. I need 8. 270, negative 180. How many do I have? 1, 2, 3, 4, 5, 6, 7. Oh, we're adding a 9th in? What's your nomination? Overachievers in here. I like it. Questions there? Okay, I'm going to walk around. All right, but everyone sees the assignment below here. Might be a good idea to try it out. I put all the answers up on Aspen, but from now until the end of class, I'm going to walk around and see you do negative 280, 605, and negative 410. Graph it and find the reference angle. And if I don't get around to you or I just walk by you without saying yes or no, I'm going to write the answers to these up here. And remember what we talked at the beginning of class today. Make them smaller if you want, if it's easier on you. Make them smaller, so maybe they're easier for you guys to graph.